Instead of blinking LEDs like we did in the previous project, this circuit senses temperature and makes a decision, just like real electronics inside robots, computers, and machines. The 555 temperature-controlled fan controller, once finished, will be a circuit that cools when the temperature rises with the use of a 12-volt DC fan and a potentiometer. The DC fan turns on when the circuit gets warm and turns off when it cools down. The fan stays off when the circuit is cool until a certain threshold is reached when the circuit warms up. Then the fan turns on. The fan stays on when the circuit is warm until a certain threshold is reached when the circuit cools down. Then the fan turns off. A potentiometer lets you adjust the temperature threshold. It uses a 555 timer as a Schmitt trigger comparator, so it doesn't chatter on and off around the threshold. A MOSFET handles the fan current safely. Instead of switching on and off at the same point, a circuit with hysteresis turns on at one level and turns off at a different level. This separation between switching points makes the circuit stable and predictable. For this project, we're using a thermistor as part of the sensor node of the circuit. A thermistor is a special type of resistor whose resistance changes with temperature. We're going to use a 10K NTC thermistor, where NTC stands for negative temperature coefficient, meaning the resistance decreases as temperature increases. A thermistor by itself only changes resistance, not voltage. To make it useful, we place it in a voltage divider with a regular resistor. As temperature rises, the thermistor's resistance drops. This causes the divider's output voltage to change. That changing voltage represents the current temperature. Heat becomes an electrical signal that the circuit can understand.